In this video, we'll look at an example of an object that is in rectilinear motion under the influence of the Earth's gravity. And here's the situation. So a projectile is fired up from ground level with an initial velocity of 16 feet per second. How long will it take for the projectile to hit the ground? It's the first question. Well, now let's think, what does that mean? All right, let's assume that ground level means that S equals 0. The position is 0. That 0 is at ground level. Okay, so what we want to do is we want to solve S of t equals 0 so that we're at ground level. All right, we want to find the time and solve this for t, of course, and that will tell us how long, all right, what times are at ground level, and we can see then how long it flew. Well, first of all we have to find S. Well, now this is an object that's under the acceleration of gravity. Since we were given units in feet, all right, we'll use that the acceleration is negative 32 feet per second squared. All right, the initial velocity, it starts with an initial velocity of 16 feet per second. We're assuming, of course, that the upward is the positive direction. Okay, and finally, since we're starting from ground level, the initial position is 0. All right, so remember, all right, that under this situation, the position function is going to be a_t squared over 2 plus v0t plus s0, excuse me, s of t is going to be negative 32 t squared over 2 plus 16t plus 0. Or that would be that S of t is equal to negative 16t squared plus 16t. And we want to find out where that's at 0, because when S is 0, the position we're located at ground level. Well, out of this I can factor 16t, and I'll be left with negative t plus 1 is equal to 0. Well, I see that if t is equal to 0, this result is 0. And I see here that if t is equal to 1, the result is 0. Now, well, of course, when t is equal to 0, that's just when the object is being fired. So that's when it's leaving the ground. It's going to be at ground level 1 second later. So the answer to this question, how long will it take for the projectile to hit the ground? The answer is going to be 1 second. How long will it take for it to hit the ground? Again, the answer is 1 second. Okay? All right. How long will the projectile be moving upward? Well, the projectile is moving upward. Remember, upward is the positive direction, as long as v of t is greater than 0. So let's find v of t. Remember that a was negative 32 feet per second squared. V naught was 16 feet per second. And S naught was 0. And now if you remember, under constant acceleration, v of t is going to be at plus v naught. So v of t is going to be negative 32t plus 16. And we want this to see it will be moving upward as long as this is positive, or as long as this is greater than 0. Well, if negative 32t plus 16 is greater than 0, then 16 is greater than 32t, dividing both sides by positive 32, so we don't have to reverse the inequality symbols. We'll have 1/2 is greater than t, or t is less than 1/2. All right, so the projectile will be moving upward for 1/2 second. Okay, now at 1/2 second, the velocity will change from being positive to negative. That's kind of the dividing point, and we'll use this in this next problem. What will be the highest point? All right. Well, we can think of this in a couple of ways. One way is physically, all right, is the object is moving up for the first half second, then it starts moving down, all right, it's going to be negative after 1/2 second, the velocity will be. So at that time, when the velocity is 0, it quits moving up and it's started moving, it's not quite moving down, so we're stopped for a moment at that highest point. All right, so that's one way to think about it. Another way to think about it is this: we're trying to maximize the position. All right, so let's see. So to maximize the position, I look for critical points. I look for where the position's derivative is 0. That means I'm looking for where the velocity is 0. So here we find what we'll have to do. We want to know how high it is. How high is position? So we want to find S when, all right, v of t is equal to 0. Now, from before, we had that S of t was equal to negative 16t squared plus 16t, and v of t was equal to negative 32t plus 16. So let's set this v of t equal to 0. All right, and when v of t is equal to 0, well, we'll have negative 32t is equal to negative 16, and so t is equal to 1/2. All right, when t is equal to 1/2, all right, let's see, I'll have to evaluate S at 1/2 at this time. I need to find out where it's located at that time at 1/2. And so that means I have to replace each instance of t with 1/2. So that'll be negative 16 times 1/2 squared plus 16 times 1/2. And that's going to be, of course, negative 16 times 1/4 plus 16 times 1/2. Negative 16 times 1/4 is negative 4, plus 16 times 1/2 is 8. So negative 4 plus 8 is 4, so it'll be 4 feet high. And that's how high it will go. Here's the position versus time function. Notice for the first half of a second, we're going upward until we reach a height of 4 feet, and then we go downward and we reach position 0, ground level. We hit the ground again at 1 second.